Hello, hello, can you hear me? Excellent. All right, I guess we're going to get started here. It looks like it's going to be a great night for observing. It's probably the first clear second Saturday we've had in a long time, so I want to get you to the telescopes as soon as we possibly can. So welcome to our October second Saturday stars. My name is Mark Polanski. I've been a volunteer here at the observatory for over 12 years. I've been imaging and taking pictures of stuff in the sky for just about as long. And tonight's presentation was supposed to be about astrophotography and the details of taking pictures of deep sky objects like galaxies and nebula. However, Thursday night I was supposed to be working on this talk, but I got a little distracted. Fortunately, one of our longtime volunteers, the always brilliant Dr. Parker Moreland, had the idea of pivoting tonight's talk to talk about something else. You see, this happened. It was by far the brightest and most vivid display of the aurora I have ever seen. Back in July of this year, I gave a second Saturday stars talk here about the aurora, how and when to see it, where it comes from, and how it happens. At the time, the May 10th aurora had just happened, and it held the crown as the most spectacular I had ever seen. This past Thursday surpassed what I saw in May by a fairly wide margin. There's also so much other exciting space news happening, we thought tonight would be a good time to talk about cool and current space stuff. And again, I know this is a pristine night for observing, so we want to get you to the telescopes, so I'll try to be as quick as possible. And if anyone does have any burning questions about astrophotography or imaging, I'll be happy to answer them at the end. So what's going on? First, we'll talk about the aurora the other night, and then on to what has the potential to be a bright, possibly naked eye visible comet. NASA's Crew 8 mission will be returning from the International Space Station in the next few days. The European Space Agency's Hera mission just launched right before the hurricane in Florida, and SpaceX's Starship vehicle could launch as early as tomorrow morning on its 5th test flight. In one of the missions I'm most excited about, NASA's Europa Clipper is about to launch as early as Monday. So we'll start with the aurora. As a quick refresher, aurora happen when plasma is burped out from the sun and hits Earth's magnetic field. These burps are called coronal mass ejections, and they're usually generated by regions of instability on the sun called sunspots. They can blast off from the sun in any direction. Sometimes we get lucky and they're pointing right at Earth. The plasma can take a few days to travel through space into our neighborhood, and when it arrives, Earth's magnetic field will deflect most of it away on the sun-facing or daytime side of the planet. On the night side, the deflected plasma can pinch or compress the tail of our magnetic field, and when the incoming plasma has enough energy, it can snap the magnetic fields together, which then accelerates the charged particles in the plasma to ridiculous speeds and funnels them right back towards Earth, slamming into and exciting the gaseous atoms in the upper atmosphere. The different colors of the aurora are generated by these excited elemental gases at different altitudes. Green is usually the most common color from oxygen at lower altitudes. Red happens with higher levels of energy or higher concentrations of plasma at higher altitudes. Blues come from nitrogen at lower altitudes. We also still haven't hit the peak of the current solar cycle, and the sun has been surprisingly active so far, surpassing all expectations. So there may yet be more chances to see the aurora over the next year or two. For a more detailed explanation of how the aurora happens, check out the McCarthy Observatory YouTube channel and look for the July 13th second Saturday stars, called the aurora. The CME that hit us the other night came courtesy of sunspot region 3848, an area much larger than the entirety of planet Earth. It blew off the sun on October 8th around 10 p.m. our time, and it was super quick. We first detected the arrival on October 10th around 1 p.m., meaning the plasma took just over a day and a half to arrive here from 92 million miles away. The aurora was immediately visible as soon as it was dark enough to see it. My all-sky camera at home was first able to pick up some of the aurora at 7:10 p.m., and it seemed to peak at about 7:37, before it tapered off by 8:15. Afterwards, it was still visible with a clear view of the northern horizon, but more as some blobby greens with occasional red streaks, nothing super exciting. I was just about to pack up my cameras and head inside around 10 p.m. when a substorm flared up, and the whole sky lit back up like nothing I've ever seen. By 10:20 or so, it had tapered back down, and I went back home to warm up because it was very cold and windy. The activity continued for the entire night, with little blips and smaller flare-ups throughout the early morning. Nothing as intense as the 10 o'clock flare-up, but it was still visible in the all-sky images. Here's what NASA's Solar and Heliospheric Observatory spacecraft saw of the CME. To identify a CME as Earth-facing, we'll usually look for a halo effect, where material can be seen shooting off in all directions at the same time, as opposed to just flares heading off here or there in any one direction. The noisy snow towards the end is also an indicator that radiation from the sun has impacted the camera sensor on the spacecraft, which is also a pretty good indication that the burst is heading our way. This is a time-lapse taken from my home-built all-sky camera. It takes pictures continuously every 1 minute, and it goes from just after sunset to just before sunrise. So here's the 7:30 flare-up, and it kind of tapers off a little bit. There's still some red there. There's still a little bit of activity. This is facing north up, so the top of the image is the north, and there's the 10 p.m. flare-up with lots of bright cyans and reds and greens. And then as the night went on, there's still just a little bit of activity. You can kind of see that red band on the bottom. And around 3 or 4 in the morning, it flares up a little bit again. So this was an all-night activity. And then we see Orion is rising on the bottom there. That bright star in the middle is Jupiter. And then eventually we get to the daytime. But this was a very prolonged event, something that we don't see very often at all. So a few days before this outburst, there were several smaller, quicker displays visible here in Connecticut of the Aurora. They only lasted about 10 or 15 minutes each, and they weren't nearly as strong as what we saw Thursday. But my all-sky camera did pick them up, and I noticed something odd. There was a persistent red band that didn't seem to move much. It was just kind of floating there. I thought it was just an artifact or noise in the camera or something else, but then I saw it again during the show Thursday. In the image on the left, you can see it on the bottom, spanning from left to right, meaning it's moving from east to west. The image on the right is from my Canon camera, taken at almost the same time, facing west. Turns out it's something called a SAR arc, or Stable Auroral Red Arc. They're fascinating things, and we keep learning new things about them. Feel free to Google them and read up on them to find out what we know so far. But my understanding is it's a visual representation of the plasma pause, or plasmaspheric boundary. The furthest point the solar plasma is pressing down on Earth's magnetic field. It's kind of like one of those kid science experiments where you use a magnet with iron shavings on paper to kind of trace out and see the shape of the magnetic field. That's kind of what this is doing, except on a planetary scale. And here's what the 10 p.m. substorm looked like on the ground. My camera was set for 6-second exposures at ISO 6400, full manual, no automatic adjustments. The camera was set with a timer to take images every 10 seconds. Nothing about the exposure or the camera changes, only the intensity of the aurora. I was actually in my car warming up, about to head back home at about 10 o'clock when I saw this unfold through the windshield. I'm super lucky I hadn't packed up this camera yet. This animation is also made from compressed JPEG images straight out of the camera. There's no manipulation or editing at all. This is just what it looks like. I do have the raw files for these, and I might eventually do a fully processed time-lapse to eke out all the detail I can. But this was unbelievable to see. It was truly awesome in the original sense of the word. The structure of the columns was clearly visible, along with the deep reds, greens, and cyan pulses. It moved and changed so quickly, and it got so bright, I had to actually stop this capture and drop the exposure time down to 2 seconds, which is why it just kind of ends like that. I really should have let it go for longer because this was just phenomenal. So here's one more look at the CME from the SOHO spacecraft, but a bit of a wider view this time. You can see the planet Mercury just to the left of the sun. There are several non-Earth-facing CMEs that happen, blowing off in different directions. But then something strange happens. This really bright thing shows up and photobombs the October 8th coronal mass ejection. This is comet C2023A3, passing between Earth and the Sun just as the October 8th CME blew off. This is a pretty exciting comet. It came from the Oort cloud, way out at the edge of the solar system, well past Pluto. It's a long-period comet, meaning it takes millions of years to orbit around the Sun. This particular comet might even be on a trajectory to be ejected from the solar system after its quick swing around the Sun. It passed the Sun at a distance of 0.39 astronomical units, which is about the distance that Mercury orbits the Sun. And it's exciting because it survived perihelion, or its closest approach to the Sun. Many comets are of the dirty snowball variety, meaning they're made of mostly water, ice, and ammonia, and they tend to melt or disintegrate as they get close to the Sun. This wasn't a sun grazer comet by any stretch, but we know Mercury gets pretty hot baking that close to the Sun, so it's impressive that it was able to hold together. And evidently enough material melted off to produce this gorgeous tail. It was seen in the pre-dawn sky just before sunrise until about October 3rd, when it crossed in front of the Sun, as we saw in the previous slide. It'll be emerging in the evening sky starting tonight, but it will only really be visible with the clear, unobstructed view of the western horizon. Unfortunately, here at the observatory, we have this lovely hill behind our building to the west, so we won't be seeing it tonight. But as it moves further and further from the Sun, the visibility will improve. The comet will set later and later in the night, meaning the sky will get darker and darker, making it easier to pick out. If there's still too much light from the setting Sun, the coma and the tail might get washed out and kind of blend into the sunset. So it's really important to wait for it to rise high enough to get away from that extra light so we can see it. The good news is, from here on out, it's going to be distancing itself from the Sun, which means it'll get higher and higher in the sky as October rolls on. If it maintains its current brightness or even brightens any further, it may become visible to the naked eye. The problem is comets are notoriously unreliable. No matter how hard we try to predict them, we just don't know enough about what any particular comet's made of to know how bright it might get. So it's always the best guess. Sometimes it'll be surprising and get brighter. Sometimes it'll kind of fizzle and be a disappointment. We've experienced both. But even if we can't see it with the naked eye, get your cameras ready, because a 2 or 3 second exposure should still be able to pick it up pretty easily, especially if it's in the 4th to 5th magnitude range. By October 16th, it should be well clear of the sunset light, and that might be the best chance to see it by eye, but away from light pollution. NASA and SpaceX's Crew 8 mission launched to the International Space Station in the Crew Dragon Endeavour on March 4th of this year. They're set to return no earlier than tomorrow, Sunday, October 13th, assuming the weather cooperates. This mission was supposed to return October 7th, but couldn't due to hurricane-related adverse weather in the recovery zones, thanks to Milton. Endeavour has the distinction of being the first operational Crew Dragon spacecraft and was named by Bob Behnken and Doug Hurley on the Demo 2 mission to the International Space Station in 2020. It returned the United States to human spaceflight for the first time since the space shuttle retired in 2011. Crew 8 is the capsule's 5th visit to the International Space Station. Once it returns, the crew will have been in space for about 220 days as part of this mission. Undocking is currently scheduled for 7:05 tomorrow morning, with a splashdown expected around 3:30 p.m. Monday, again, assuming the weather cooperates, in one of the recovery zones off the coast of Florida. The Hera mission launched earlier this week on October 7th. It's heading towards the double asteroid Didymus and Dimorphos. Didymus is a potentially hazardous asteroid whose orbit brings it as close as 15 lunar distances from Earth, with an average diameter of about 765 meters. That may not sound very close, but in terms of the size of the solar system, it's pretty close. Close enough for us to be worried about it. Dimorphos is a small companion, like a little moon, orbiting Didymus, with an average diameter of about 160 meters. Hera is a spacecraft developed by the European Space Agency to follow up on NASA's DART mission, which was the Double Asteroid Redirection Test. DART's intention was to test the feasibility of intentionally crashing a spacecraft into an asteroid to try to nudge its trajectory. The animation here is made up from actual images taken by DART in real time as it successfully approached and impacted Dimorphos on September 26th of 2022. Hera is meant to be a follow-up and take detailed measurements and photos of the aftermath of the DART impact, as well as characterize the properties of both Didymus and Dimorphos, with more detailed looks at their composition, internal structures, and their orbital properties following DART's impact. It will arrive and enter orbit around Didymus in December of 2026. SpaceX's Starship vehicle, the world's largest and most powerful rocket, is set to embark on its 5th test flight as early as tomorrow morning. They just got the FAA approval a few hours ago, so they are ready to go. This flight will pair Booster 12 and Ship 30, building on the progress of the previous 4 test flights. The intention is for Starship to be a fully reusable spacecraft, where both stages can be returned to the launch site and rapidly reflown, like an airplane. Right now, the Falcon 9 rocket is the only reusable rocket flying, and it's only able to reuse the first stage booster. The second stage is expended on every mission. One of the more ambitious objectives with Flight 5 is to attempt to actually catch the booster as it comes back to the pad. Unlike the Falcon 9 boosters, the Super Heavy booster doesn't have landing gear, so it can't land on a pad, and it's far too large to land on a barge. So instead, it's going to fly back to the launch tower and settle down between those 2 large arms at the top of the tower. So far, each flight has improved upon the last, with Flight 4 achieving all of its test objectives, including a soft-powered splashdown of both the booster and the ship vehicles, even though the ship got a little toasty and melty on the way back down. The booster came down within a half a centimeter of its target, so they have fairly high confidence in the booster for Flight 5 having enough precision and control to be caught midair as it comes down. People think it's a crazy idea, and it kind of is, but many of the same people thought landing a booster on a small barge in the middle of the ocean was crazy too. And SpaceX has done that well over 300 times now. It's important to note these are very much test flights. SpaceX has taken the rapid iteration approach of test, fly, fix, repeat. It's not yet an operational rocket. So no payloads are flying and certainly no people. An important test data is gathered on each flight regardless of the outcome, which feeds engineering improvements which goes directly into the next test flight. Whether the catch works or not, it will be exciting. Starship is critical to NASA's Artemis program, as Starship was selected as the human landing system to land humans on the surface of the moon for the first time since the Apollo missions. And Europa Clipper. This is exciting for a number of reasons. As the name implies, it's meant to study Jupiter's moon Europa. Europa is the 6th closest moon to Jupiter out of 95 known moons, and the 6th largest moon in the whole solar system. It's only slightly smaller than Earth's moon. There's evidence of Europa having a vast ocean of liquid water under the frozen crust, with a very thin oxygen atmosphere. It may even have an iron-nickel core, just like Earth. It has a heat source through tidal friction and flexing due to its proximity to Jupiter. It's one of the few places in the solar system that potentially has all the ingredients to support life as we know it. And one of the primary objectives of this mission is to assess and study the habitability. Because of the close proximity to the planet, Europa is well within Jupiter's magnetosphere and subject to very, very high doses of radiation. Instead of orbiting Europa directly, the Clipper spacecraft will enter into an elliptical orbit around Jupiter and explore Europa via flybys to limit the radiation exposure. The mission is set to launch no earlier than this Monday, October 14th, on a SpaceX Falcon Heavy rocket. It will use gravity assists from Mars in February 2025 and then swing back by Earth for another gravity assist in December of 2026 before arriving in the Jovian system and Europa in April of 2030. The science payload is impressive, with several kinds of cameras, imagers, and experiments to help reveal some of Europa's secrets. Most of what we currently know about Europa comes from the Galileo spacecraft, which orbited Jupiter from 1995 until 2003, so it's been a while since we've been there. Galileo was guided into a controlled entry into Jupiter's atmosphere as a protective measure to make sure that no Earth contaminants accidentally land on Europa and potentially spoil any kind of life that might be there. Clipper's mission is intended to last about 4 years once it arrives in 2030. The animation here shows the intended trajectory and orbital insertion once it gets to Jupiter. The pink line is Europa, the spacecraft itself, or the Europa Clipper spacecraft. The green dot in the center is Jupiter, and the teal circle is Europa's orbit around Jupiter. You can see the elliptical pattern the Clipper will take as it swings in for close looks at Europa and then back out beyond Callisto to reduce exposure to the intense radiation around Jupiter. Here's the Clipper spacecraft getting encapsulated in its payload fairing, which will protect it from Earth's atmosphere during launch. While the boosters on the Falcon Heavy normally have the potential to land and be reused, the performance requirements for this mission with the mass and trajectory mean it will need to be expended, so we're not going to see that exciting double landing this time. But that does mean that Clipper will get to Jupiter faster, so we can get down to science sooner. We wish the Europa Clipper team the best of luck on this launch and look forward to the wealth of science coming at the start of the next decade. Anybody have any questions? this was probably my favorite animation of images that I took of the aurora. The projector's not really doing it justice here, where it's kind of blowing out some of the details there. But this is what I saw at 10 o'clock when I was about to pack up. This was one of the craziest things I've ever seen. And it wasn't quite that bright and vivid, but I could very easily see the reds, I could very easily see the greens, and I could very easily see that light blue up on top. This was absolutely wild to see.
Question?
Yep.
Somebody else has one. Things like this, do you see possible, if not conclusive, relationship between that and global warming?
The question is there any kind of a relationship between what we're seeing here and global warming? The answer is no, because this is relatively small amounts of plasma coming from the sun, and most of that's getting deflected away from the magnetic field. So the amount of energy being dissipated here is very short-lived. There's not a tremendous amount that actually stays within the atmosphere. A lot of this energy is just exciting the oxygen atoms and nitrogen atoms in the atmosphere, and then they eventually calm back down and release that energy as light. So almost all of that energy incoming is getting converted to light. So none of that's actually getting absorbed into the atmosphere and causing any kind of warming.
Okay, I was saying not causing it, but whether you did answer the question, this is outside of whatever's warming on Earth.
Oh yeah. Yep. Yeah. This is well beyond the troposphere and upper atmosphere. This is kind of way out there by the Kármán line. So it's basically like at the level of space. This did happen similarly in May of this year, May 10th. That's the only other time that I've seen a display even close to this, and again, this, at least in my eyes, surpassed it, just from what I could see with my eyes. The Aurora presentation that I gave back in July has a little bit more details about the solar cycles and what that usually means for seeing the aurora. The long story short is the sun goes through 11-year periods of activity, where there's a ramp up in activity and then a taper down in activity, and this kind of sine wave of high activity and low activity repeating every 11 years. So we are approaching what's called the solar maximum of solar cycle 25 right now, and it's due to peak into late 2025 and early 2026 before it starts to taper back down again. So from a solar physics perspective, we are theoretically still on the uptick of activity. So if the sun continues to stay active, and there's a lot of sunspot activity and a lot of coronal mass ejections, there's a very good chance that we're going to see more of this over the next year to year and a half. It may not be as brilliant, it may be just little bits at a time, but there's certainly a much higher chance of seeing something like this again than if we were close to the solar minimum. Yeah. That's the Hera. The question is, what's the mission going to Didymus? It's the European Space Agency's Hera spacecraft.
Now, there's enough gravity for that for it to orbit?
Yeah, just about. It's kind of like, I don't think I had an animation of how it's actually going to get there, but in researching it, I saw how it's actually going to approach the asteroid. This asteroid is relatively small. It's only about 800, 750 meters in diameter. That's still enough to have a gravitational pull because it has a moon orbiting it. And both the Hera spacecraft and DART are very likely less massive than that moon. And if it has enough mass to capture a little moon, then it does have enough to orbit the spacecraft. The approach has to be careful though, because you're also basically orbiting the sun. Like the Hera spacecraft, when it was launched last week, was launched into a heliocentric orbit, meaning it's now orbiting the sun. It was launched into a very similar trajectory to the asteroid itself, so they're both kind of like following each other. And the idea is, over the next year and a half or 2 years, Hera's just going to get closer and closer and closer. It's going a little bit faster than the asteroid. And the idea is it's going to get there, fire its thrusters to slow down, and if they're going at roughly the same speed, it can get captured by the very small gravity well at the asteroid.
Excuse me, you just said the size
Yep.
I'm not so good on my math, but wouldn't that be about the size of the high school here?
Actually, yeah. Pretty close.
I get lucky.
Yeah, not an enormous thing, but you know, when you're out there, any kind of a dense core of something is going to have enough gravity to affect what's around it. All right, so this is what we might be able to see tonight. Obviously, the moon is right there; can't really miss it. The next brightest thing over to its left is Saturn, so we'll hopefully have a couple telescopes pointing there. We'll likely have one or more telescopes pointing at the Andromeda Galaxy at some point, maybe even the Dumbbell Nebula. That might be a little bit more of a stretch, given that the moon is pretty bright right now. Might wash it out. We'll probably point at Albireo. And I didn't write down, but M13 is a star cluster that we might be pointing at too. So a lot of good stuff to see tonight. It looks really clear. There might be some slight overcast, but that shouldn't really impact most of our observing. So thank you very much, and join us November 9th for our next Second Saturday Stars, and enjoy the clear evening.